Hi everyone, Sammy here to talk to you about HSMA session 2B exercise 1. So this was the exercise in which we were building a discrete event simulation model of a GP surgery. Now, in this exercise, we have been tasked with building this model that's shown in this diagram over here. So we have two types of patients coming in. We've got patients actually physically coming to a GP surgery and people who are calling the GP surgery. They each go through a different process. So those that arrive at GP surgery go through registration using a receptionist resource. Then they will all go on to a GP consultation requiring a GP resource. At this point, they split off into two groups, so 25% of patients will need to book a test, 75% of patients will just leave the GP surgery at that point, so that is one of our sinks, one of the ways out of the model. For those that book a test, they have gone back to the receptionist, so they're using this same resource again, and the patients, after they've booked this test, will then leave the GP surgery. We also have people calling GP surgery, so this is a separate pool of people, it looks like, and actually they will be answering, the receptionist will be answering the call, and then the call will end, and again we have a sync where these people, these entities, will leave the model. So what we've been told is that every 3 minutes patients actually arrive into the GP surgery, so that's these ones up here. They will spend around 2 minutes being registered, so using this receptionist for around about 2 minutes, and they will spend around about 8 minutes with the GP. Now, about a quarter of these patients will then need to book a test at reception, as we've said. Booking the test takes around 4 minutes. Receptionists are also answering those calls. The calls are only coming in around every 10 minutes, but they're lasting around about 4 minutes. So I keep saying around about because we're not going to be using exactly 3 minutes, exactly 2 minutes, etc. for each of these activity times. It's not very realistic if we do that. It's also very deterministic. We don't really see any variation in the model runs. We don't get a sense of how well things will go on a good day, how well things will go on a bad day. So actually by having this variation, we can simulate almost 100 different days in this GP surgery with this slight variation taking place, but also sort of still reflecting reality, kind of being somewhat around this prior pattern that this GP surgery have seen of how long things take. So we've also been told that surgery currently has one receptionist, two GPs, and they want us to build a simulation model because there are lots of complaints coming in about lengthy delays. We're going to have at least 100 runs of the simulation, and actually at the moment they're only interested in queuing times. They don't really care about seeing how long the activity times in the model are taking, although we could store this in a later iteration of the model if we so wished. They want to look at the patients and the callers separately, and they want the average results as a minimum, but we can go further and provide additional stuff. We also need to calculate the mean queuing times across the trial, so mean queues across registration for all of runs. So every time, if we've got 100 of these runs of the simulation, almost these 100 days, then actually we want to see the average across all of these. And once we've built the model, we're going to use it to identify where the problem is, and we're going to try and come up with some proposals for how we might be able to fix it. So I might split this into a few videos just as there's quite a lot to go through here. But what I'm going to do first is talk a little bit about how I would approach this exercise myself. So in the HSMA 2B exercise repository on GitHub, we have been provided a couple of lecture examples. So we've got Simpy example 1, which is a simple one-step model. We've also got Simpy example 2, which is a two-step model. We've got Simpy example 3, which also incorporates this branching. Now, I could go straight to Simpy example 3, copy what's there and start modifying it to reflect what I'm trying to do in these models. However, my personal preference is not to do that. I would prefer to actually, and if I bring this onto the screen here, when I'm building a new model, I will start with the simplest possible case first. So I will actually just code in patients arriving at the GP surgery, so just people turning up, and I will then deal with the registration with one single kind of resource, and then I will get people to leave, just so that I can get my head around what this model needs to look like, get all the structure in place for it. Then it becomes really rather simpler to go through and go, right, okay, I'm going to add in this extra step. I'm going to add in this branching step. And then finally, we're going to be able to deal with this other step of this additional source of people coming in, these calls being answered, the receptionist dealing with them, etc. So I find this sort of sequential build up to be a really good way of working. That doesn't mean it's the right way or the only way. It's absolutely legitimate to go to the exercise 3 example, modify it from there. But I find that writing the code from scratch, actually typing it all out and thinking about it that way. So I will have the exercise example open and we'll be referring back to that throughout. But writing the code out myself from scratch really helps me to think about why I'm doing everything, why I'm doing each step, what each step means. And it just means I'm a little less likely as well to actually leave something, like leave a default value or leave something named incorrectly, or not named particularly descriptively. Instead, I know what I'm doing and why I'm doing it. So let's kick off. The first thing, I'm working in a notebook because again I just find that a helpful way to work. I'm going to create a cell where I'm going to import Simpy, I'm going to import random, and I'm going to import pandas PD because we will need all of those three. Simpy is our simulation environment, or our simulation package. It allows us access to a large range of functions that are designed to help with simulation problems. Random is a built-in Python library, so it comes with Python. We don't have to install this separately. And that is a library that allows us to sample random numbers, make random choices from lists, all that sort of lovely thing. We've then got pandas as well. Pandas is almost our Excel-like environment. It allows us to create tables of data and manipulate them, do nice things with them. So I'm going to select my kernel. I have previously created a discrete event simulation environment using the environment.yaml file that is available inside this Simpy GitHub repository. So there is a different video on how to do that if this is something you're interested in, if you haven't done that before. However, the des environment, you can also just create that manually yourself by making sure you've installed, pip installed Simpy, pandas and numpy. The versions shouldn't matter too much in this case, but we do recommend a couple of particular versions in that environment.yaml file. So I'm going to select this des environment, and you can see that the complaint messages about the fact that it couldn't find Simpy or pandas in the environment have now disappeared. So the nice thing about doing this in a separate cell is I can just execute it, run it once, and actually I don't have to worry about that cell again for the rest of what we're doing. So first thing I'm going to do is create my class to store the global parameter values, our G class. So as we said in the lectures, we follow a very rigid structure for creating models. It's not the only way, it's not the only structure we could use. Actually, you will find a lot of models out there in the wild that do have different structures, but this is effectively not a big problem. It's it's something that you will learn to recognize other people's ways of doing this. So instead of having a G class, a very popular method that we see is having a scenario class that allows you to easily pass around different situations. So actually you can see here we've got number of nurses equals 1. Well, you might have a class where you allow people to pass in how many nurses they want when they create that parameter class, that scenario class. Don't worry about that for now. Just be aware that this is the method we will use throughout the Simpy course. It's also the method used throughout the Simpy book that accompanies the course, but it is not the only way. So all that being said, let's create our G class. So remembering that in our model at the moment, all we're actually doing is having, well, rather than doing the whole thing, we're just doing this first step, the registration and patients arriving at the GP surgery and leaving. So all we care about is how many receptionists have we got, how frequently do people arrive, and how long does registering them take on average. So we're going to create our class G, our patient into arrival time, which I think we can still just call that the same thing. Patient inter. I'm going to change this to IAT. I find that a little bit easier to remember. So patient inter arrival time rather than just patient inter. And we know that they arrive into the GP surgery around about every 3 minutes. Then we've got the mean, what do we call it? Mean registration time. Don't want to make these names, variable names, too long particularly, but actually this sort of length is probably fine for our purposes. And I find the descriptiveness is better than not being descriptive enough. So they take on average 2 minutes to be registered. Number of receptionists, we're going to call, so we've got one receptionist, I think it was in the default. Let's just check that. Yeah, one receptionist, two GPs. We want to run the simulation for, well, a day in the life, I think they said. So how long will that be? Let me just have a think about that. Right, so we've got 8 hours of the surgery being open. So it's one day in the life open to in-person patients and telephone callers for 8 hours continuously. So I'm going to run my simulation in minutes rather than seconds or anything like that. I think everything we've been talking about so far has been in minutes. We can have, when we sample, we might find that actually, someone spends 2.3 minutes being registered, but we don't really have to worry too much about that. Everything I've done so far, so this patient into arrival time, etc., is in minutes. So what I'm going to do is I'm going to get Python to do what it's good at and calculate the length for me. So I'm going to say 8 hours times 60, the sim duration. So I want 8 hours, 60 minutes long, and what that will calculate is 6 times 80 for me and store that in the sim duration. So actually then it becomes a little bit easier rather than having to go away and manually calculate how long is 6, so it would be what, 480 minutes. So, but if I wanted to do 7 hours, say, change the opening times, then that becomes a lot easier to do rather than having to do a little bit of maths. And the other thing we want is the number of runs. So we're going to have the number of runs. We've been told that we wanted 100 runs of this simulation. And that's all that's going in our class G for now. We will come back later on and add in, for example, the caller into arrival time, the length of time that it takes for a GP to work with our patients, etc. But we don't need that right now. Next thing we're going to do is create our patient class. So for now, our patient class won't need to store much. We create class.patient and we create our init method, and all we're going to want to pass in is a patient ID, which we will generate. Well, we'll be keeping track of basically how many patients have come in. Having a patient ID is really helpful because then we can store that patient's results in a data frame against their ID, and we can just keep track of which patient had what wait time for different stages of the process. We can track that patient's journey through our simulation effectively. So we're going to say that we're going to call it self ID. They're going to have an attribute called ID, which is going to be this ID that gets passed in. And we're going to also just record their queue time for the receptionist. And we're going to set that to a default of 0. So when the model initializes, they have not queued for a receptionist yet. Now, this could be a little bit iffy, I suppose, because actually maybe we don't want, if we do this, then actually anyone that well, it depends when we record our queue time. We'll come back to that, but it's just worth kind of thinking about whether your default values that you're setting could cause any confusion later in the model. So actually, could you end up thinking that someone did get to the point of seeing the doctor further in the process when actually they just never got past the receptionist, but because you're seeing a value that they had a queue time of 0, you might accidentally include that. That actually might not be a problem in this case. We'll have a think about it later when we get to modelling that part of the problem. So, class patient, that's all sorted. Perfect. That's all we need for now. Again, we've been told we don't need to record the activity time, we just want to record for that individual patient how long did they queue for the receptionist. We're now going to look at the model. So I'm going to, again, def init. All I care about here is what run number is this model. We will pass that in to the model, and we are going to start out by creating a Simpy environment. So this is, we're going to store the environment as an attribute of the model. So actually, every time we want to access the environment within this model, then we don't have to, well, it's there ready for us to pass around, and we do need to pass it around to a lot of Simpy functions, so it's very important to have it stored somewhere. Now, What is a Simpy environment? You can just think of it as a virtual world, effectively. It's just a world that's initialized where everything, time will tick on and everything will take place. So all we need to do for this is Simpy environment, and that's it. We've initialized our environment. So when we create a new model, then the Simpy environment will be created for that particular run of the model. Now, we're going to also have a patient counter. So remember, we were talking about this ID attribute up here. This is what's going to be passed in when we generate patients. So I'm going to do self patient count, and we're going to start at 0. We've not had any patients at the beginning. We're then going to create our resources. So I'm going to start commenting this up actually a little bit. I should do more comments than this really, but just for making it a little bit easier to track for now, I'm not going to. But here I'm going to do a little header that says resource creation. So actually when we come back and add in our additional resources, our GPs, etc., then it's a little bit easier to find where we did this before. So I'm going to say self.receptionist, and that's going to be a Simpy resource. Oh, Simpy dot resource even. Nope, not real-time environment, resource. There we go. Now into this, I need to pass as the first argument the Simpy environment that we've created. And again, remember, we've created this as an attribute of this model, so we can just refer back to self.env rather than, we don't want to create a new environment here or everything will get very messy because everyone will be off in their own little virtual worlds. We want the environment that everything is going to be running in, which is this self.env. Now, the capacity of this resource, so the capacity is just effectively how many nurses do we have. So it's almost like slots, and what you will find is you will have a patient come in, they will hog that resource, they will hog that receptionist until they are done doing what they need to, so then until they finish registering, and then they will release that receptionist for the next person to use. So effectively, if you only have one receptionist, then you can only see one person at a time. Two receptionists can see two people at a time, so on and so forth. So we need to tell Simpy how many of those we want. I'm actually going to put this on a new line just because, again, I find it a little bit easier to keep track of what's going on. So I'm going to put capacity, and this is where we refer back to our global class. And this is where this global class starts becoming really powerful because we can start changing these values very easily, and everything else can run independently of that. So number of receptionists, we want G dot number of receptionists, and that's our receptionist created. Now we're going to also store this run number. So again, you can see I'm just really following the structure of this. This is all stuff that we need to do every time. So it's actually basically create an environment, create some way of tracking our patients or our entities. That could be, customers if we're, in a bank, in a restaurant, anything like that. But here with healthcare models, we tend to be looking at patients or service users. So what we are going to have here next is the run number. So self.run number equals run number. And to be honest, I might pop this all up here just for my own tidiness, because actually this is the stuff that we're always doing. Regardless, this resource creation is stuff that's a bit more flexible. So the next thing I'm going to do is create data frame of patient level results. So when we then add in extra things that we're going to want to keep track of, then we will be putting this in here. So I'm going to create a new data frame, and I'm going to store this again against our model. It's an attribute of our model, so I'll be able to run whatever we call our model dot results df and get at this data frame at any point, but I'm going to create it as a blank data frame. Now, it's important when you create this data frame, you need to give it effectively the way we're building it here is we're creating a completely blank data frame, and then we're creating a column for patient ID, a column for queuing time of whatever we want to call this queue time, so it will be queue time receptionist, for example. And then if we don't tell it what these columns are called, when we then try and set the values later on when we're iterating through at a patient by patient level, we'll run into problems. It won't know how to store these. So instead we go with self.results data frame, and it's important first that we make the patient ID. Otherwise, if we don't record the patient ID, what will happen is it will just keep overwriting and overwriting again. So we won't really actually get any iteration of results will just have patient one, and then actually patient two will overwrite patient one, and patient three will overwrite, then it just, it won't work effectively as a storage method for our results. So first thing I'm going to do is I'm going to create a patient ID column, and I'm just going to put a placeholder value of 1 in there. I've made this a list. That's just what it's expecting as the input rather than just a single value. That I don't think will work, so we just want a list that gets passed in. I'm also going to do self.results df, and I'm going to do q receptionist, and that I'm going to set as, and this is important, I'm going to set it as a float. So I'm not setting it, if I just did 0, we might run into some problems later where it's expecting the input to that column to be a whole number, 0, 1, 2, 3, etc. It won't be able necessarily to deal with having multiple, with having decimal places in there, whereas our queue times are very likely to involve decimal places. We're not actually sampling a whole number, and we don't want to sample a whole number because it's quite likely that someone might spend 2 minutes and 10 seconds queuing for a nurse or a receptionist. So important to say 0.0. Now actually, I'm going to create a new code cell here just so we can demonstrate what we've got so far in our model class. So I'm going to just create my test model equals, and it's a new model class. Oh, doesn't like that. Oh, and that's because we haven't passed in the run number, so we'll just say it's run number 1 for now. So that's created successfully this time. Now, just to show you what the results data frame looks like when we've done this so far. Doesn't like it. Oh, that's because I tried to call results df as a method rather than as an attribute. I don't need those brackets. Right, results df. So you can see we've got a column called patient ID. At the moment it just says 1 in it, and we've got a queue time for the receptionist, which at the moment just has a value of 0. Next thing we're going to do is we're going to set the results data frame, and we're going to want to set the index. And this just means instead of having this 0, 1, 2 that will build up down here, the patient ID will actually be our index, and this just works better for our purposes. I'm going to say in place equals true, so that means that instead of having to go self results df index equals set index, so just basically this says please take results df or self.results df, change the index to patient ID, and actually just kind of save that to that particular object. So save it to results df. Now, if I run this again, so it's important here that I have to rerun this cell where I've been actually saying what the classes are defined as, and then I rerun my test model. And you can see this time the data frame we created looks a little bit different. So we've got queue time receptionist here, and now patient ID is over on the left here, sort of indented down almost. We've got patient ID is 1, and actually then we don't have this additional column of which was our original index, which would have been counting up from 0. We don't need 2 index columns in this particular instance. It doesn't really make sense to have that. It would just potentially get a little bit confusing. So that's what we've done so far. Let's now create our, well, we're going to want to store, so here we're going to store mean times run. And this is where it can sometimes get a little bit confusing because we're going to be storing the average times for the run, and we're also going to be storing the average times later on across all our runs. So it can be a little bit tricky sometimes to keep track of where you're storing what and why. So here I'm just going to store the mean times for the run, and I'm going to say mean queue time receptionist, and I'm going to call this, I'm going to add in run here just for me to keep track of that this is our run mean queuing time. You don't have to do that. You could follow more closely what's done in this Simpy example over here. But actually, I personally sometimes find myself losing track of whether I'm looking at the run average or the trial average. So the trial will be this sort of 100 odd runs that we have. So it's important to keep track of which is which. So that's everything we need to store when we initialize our model. So what we're going to do next is actually generate our patients turning up effectively. So you can see I've gone back to the same level of indentation as definite here. I've not stayed indented at this level. So this is a separate method of our model class that we are creating. So generator patient arrivals, As usual, we just pass in self as we always do generally when we're creating a new method. And what we're going to do is we're going to have an infinite loop. So until the simulation stops running, we're going to keep generating patients. So I'm going to do while true. And if we didn't have this while true, it would just generate one patient and stop, which is no use to us whatsoever. So instead, we're just saying, just keep going through this. And because we don't provide a way for it to break out of the loop will only be broken when our simulation stops running, and Simpy deals with that part in a different part of the code. So we don't have to worry too much. All we know is we need to run this infinite loop effectively for as long as the simulation is going. So the first thing I'm going to do is just actually go, we've got a new patient. Remember, our patient counter started at what? At 0. If we go back up here, so actually this means that the first time this runs, we will have patient 1. We won't have patient 0. The great thing about having patient 1 is that when we then put them into our data frame, they will overwrite this value, this default value that we put in there. And that's why we had 1 as our first value in here, not 0. So first patient that comes through has a patient counter, or we iterate this patient counter, and it will be patient 1, which is their ID. What we do then is we create a new patient. So we've got this patient class that we created, and remember, we just need to pass in an ID that will be assigned to the ID variable of that patient. So p equals patient, and we're going to do self.patient counter. So that will be their ID. We could always make this more explicit by putting this in, and actually it's not ID, it's PID that we pass in. So even that gets assigned to something called ID, but we pass in PID as our attribute. So I'm going to just put PID equals self patient counter. Just makes it a little bit easier to keep track of what on earth we're passing around, but not obligatory. This would also work absolutely fine. So next thing we're going to do is we're going to pass our patients to a method we haven't created yet. That seems a little bit weird, but that kind of running it in this sort of order probably makes the most sense. You could move your methods around within the model class if this doesn't make sense to you. I'll show this a little bit more when we get onto the method that we're about to generate. But what we're going to do is we're going to say, please start the attend clinic generator function with this patient, as it says here, and then we will be passing that patient through the clinic journey, through their own personal journey through our clinic. So it's self end of process, and don't worry too much about exactly what that means, but just remember that you will be passing a lot. This is a Simpy thing, and again, remember we've passed in our environment, and because we passed in self here, we can access this environment that we created when we initialized our model class. So self end process, and we're going to say self dot attend clinic, and we're going to pass the patient to that. So in a minute, you're going to see we're going to create a def end clinic method that is going to require a patient to be passed in. I'm just going to put pass for now. That means this attend clinic method just doesn't do anything. But you just so you can start to see what we're doing here, we're saying we have an attend clinic method that belongs to our model class. So we're going, please look at the attend clinic method, look at self, look at the attend clinic method, and we're going to pass a patient to this method so that they can go through their own personal journey. Now, we'll come back to what that method is going to do in a second, but first we need to finish the process of our generator of patient arrivals. So we've now chucked that patient into their own journey through the clinic. We don't have to worry about them anymore. What we need to worry about next is how long do we wait until another patient turns up. So what we're going to do is we're going to sample an inter-arrival time for those patients. Now, so we're going to say time until next patient. We could call it sampled inter. That's what this is, effectively a sampled inter-arrival time, the length of time that will be between the patients. I just find it a little bit easier to think of it as the time until the next patient. So we're going to use the random library, and we're going to use expovariate, which is an exponential distribution effectively. And all you need to remember is to get an inter-arrival time based on a distribution, you do 1.0, And again, remember this whole thing about if you divide an integer by a float, things go a little bit confusing. Or, well, no, if you divided an integer by another integer, which is what our inter-arrival time is, you'll get an integer, even if actually the numbers that we generate aren't integers. So let's say, for example, if we did 1 divided by 5. Oh, it does work. Okay, ignore me. I'm talking nonsense at this point. But either way, let's just do 1.0 divided by g dot patient inter arrival time. So IAT we've got here. Over here we have g dot patient inter. Same thing. We called it the patient inter arrival time, patient IAT, just because that I find easier to remember. So patient IAT, so it will do 1 divided by 3 to get the lambda value of our exponential variation, of our exponential curve. All that means is effectively the average value, the most common value in our distribution will be 3, and then actually there will be some patients who have a little bit less than 3 as their inter-arrival time. So sometimes we'll get patients turning up more frequently, and sometimes we'll get patients turning up more frequently. But it will be centered around an average of 3. And actually, I might be not explaining that quite right. That might not be where the peak is, but effectively what it means is if you sampled many, many times from this variation, from this distribution even, then actually the average you would get across, say, 1,000, 10,000 samples is going to be somewhere around 3 minutes if you pass in 1/3 minutes as your value of lambda. So don't worry too much, just remember that actually this is the line of code you need. Next, we are going to say yield self.env.timeout. And we're going to say this, please wait, effectively. So sample how long it's going to be until our next patient arrives, and then wait until the next patient arrives. So this process of generating new patients will pause until this length of time has elapsed in our simulation. So again, remember we're referring back to our simulated environment that we've created, and we're just going to say, please wait until the next patient turns up. And that's when is the next patient going to turn up? They're going to turn up, well, after however many time units, in this case minutes, have been generated from this time until next patient. So what does this mean? We are going to, well, we've basically finished this section. So again, we're going to wait, and then we're going to go back up to the top of this loop, iterate one on the patient counter. So now we're on patient 2, generate a patient, pass them to the clinic method, wait until the next patient turns up, and then, well, generate how long we're going to wait, and then wait and go back, and so on and so forth. So now we actually need to do something with these people while they're at the clinic. First thing I'm going to do for this individual patient, I'm going to go, when did they start queuing? So we're going to keep track of when they started queuing for the receptionist. Self.n.now. So don't worry, basically we're doing this, instead of saying self.queueReceptionist, we haven't stored that anywhere. We haven't stored that as part of our method, our model class. So here, remember, we're passing in self. We're also passing in a patient class that we could have saved it to, but again, it's probably not worth recording when did they start queuing, when did they stop queuing, etc. You can do it. It's absolutely, you might find that you do want to keep track exactly of when each patient started queuing, stopped queuing at every single point in their process, because that can create some quite interesting outputs. But for these purposes, we're just going to temporarily store start queue receptionist. We're not going to save it anywhere else. We're just going to use it inside this method, and then after this method has finished running, it's discarded. We don't have to worry about it again. So we're going to start queuing for the receptionist. We are then going to request a receptionist resource. So we're going to say with self dot receptionist dot request rep. So all we need to do here, all that's happening effectively, is we are saying effectively self.env, where were we? Sorry, not self.receptionist, so self.receptionist. We're looking at this receptionist object that we created as part of our model. And as part of this model, so we created this receptionist, we're now going to say, please ask for one of these receptionists. And what will happen is until we have, well, we're going to then run one other important bit of code, yield rec. So just remember this little kind of pattern is basically saying, please ask for a receptionist or whatever other kind of resource we'll be able to put here, and then wait until a receptionist is available before you carry on with any of the rest of the code. So and if that receptionist is busy with one other person, then we'll be put in a queue and we won't get that receptionist. We might be behind 4, 5, 6 other people in this queue. So next thing we've got is we're going to record when we have stopped queuing. So we're going to have the end queue for our receptionist, which is going to be self.env.now. So again, self.env.now just goes, please check what time it is in our simulation right now. So we're going to do self.env.now, and then we're going to record, and this time we are going to save it to our patient class. So we're going to store patient.queueTime receptionist. I think that's what we called it. So remember, this time we actually want to make sure we are recording it against this attribute of the patient class that we created. So self.queueTime.receptionist. So patient queueTime receptionist, and this will just be the time they stopped queuing minus the time they started queuing. So the queue time of the receptionist. So let's think, for example, if they ended queuing at minute 180 of our model, and they started queuing at minute 170. All this means is they queued for 10 minutes. So 180 minus 170, then we've got 10 minutes of queuing time. So that is now recorded on our patient attribute. The next thing we're going to do is sample how long they spent seeing the receptionist in this case. So we're going to do sampled receptionist activity time. So this is quite a long name, to be honest. It's not ideal, but let's just for clarity, we'll call it this for now. We could call it Act T or something, but just so we can keep track of, well, actually, I'm going to call it something different. Let's just call it time with receptionist. So again, remembering we're sampling here from a distribution. I'm going to use the expovariate distribution, again, the exponential distribution. Why are we doing this? Because actually, in reality, activity times, so inter-arrival times very commonly do follow an exponential distribution. Activity times tend not to. They tend to probably be something more like a log normal distribution. We'll talk more about distributions a little bit further down the line, but for now, what's a good idea when you start writing out your models is just start everything with an exponential distribution. It's a nice, easy distribution to code in, and you can always come back and make it more realistic later. For now, we're just interested in getting the model working. So, with that said, this time we want 1.0. Again, this looks very familiar because we did it just a minute ago with the inter-arrival time, but this time we're going to do G. So we're going back to our global, our G class, and we want how long do they tend to take to be registered. So mean registration time. And that's it. We now know how long they spent with the receptionist. Now, we're going to do two things at this point. We're going to record how long they spent with, well, actually, we're not going to record how long they spent with the nurse or receptionist in this case, because we've been told we don't actually care about this for this model. So I'm just going to do self.results.df. I'm going to store, well, I'm going to do at, and then I'm going to say for this patient ID, so we're going to have patient.id, which is effectively going to become this column here. Please store in the queue time receptionist column, so this bit here, how long they queued for the nurse. Not the nurse, the receptionist in our case. So patient, and remember we stored this against our patient object so we can access it again from our patient object. Patient queue time receptionist. And finally, we are going to wait until they have finished being seen by the nurse, by the receptionist even. So we're going to wait until for however long this time takes to elapse. So what we said on average, it takes about 2 minutes for them to be registered. Let's assume this patient takes 3.5 minutes, slightly more complex, or they weren't properly on the system or something like that. So we're going to wait 3.5 simulation units, and then when this is done, because we've reached the end of our with indented block, so this all runs whilst holding on to the receptionist object or the receptionist resource. At the end of this block, we relinquish this receptionist resource. We go, thank you very much, we're finished with you now. You can go back into this pool of resources or this pool of receptionists who are available to see another patient. If there is someone sitting in our queue of people who've not yet been seen, well, then they will actually be seen straight away. The receptionist will immediately become busy again. If there is no one there, then the receptionist is idle. The receptionist is doing nothing until there is another patient to be seen. So, what are we going to do next? We are going to calculate our run results. So this is another new method. So you can see again, I've indented, oh, not self, there we go. I've indented or gone back to this same level of indentation as our attend clinic method and our generate patient arrivals. This is just going to calculate the mean time that we spend across the whole. So if we've got 100 patients, we're going to calculate the average time that all of those patients spent queuing. So we're going to say that if we've got 100 patients, we're going to add up all of those patient queue times. So maybe the first one queued for 0 minutes most likely because there was no one else in the system at that time. Next one might have queued for 3 minutes, 5 minutes. The next one queued for 8 minutes, so on and so forth. Maybe then there was a bit of a lull, and actually the people, we cleared out our queue, so maybe then someone queued for 0 minutes again, but then we had a little flurry and the queues kind of built up again. So we're going to add up all of those queue times and we're going to divide by the number of patients that there were. Now, queue times can be a little bit skewed when we do the mean queue time because, again, of these people that turned up at the very beginning, and also the very long queues that might build up if our system gets itself into a bit of a tiz and is sort of backing up the number of people in our queue. However, the mean is a good way to compare across multiple simulation runs, and it's a fantastic starting point for calculating how well the system is performing. So we are going to remember we created this, did we create something up here? Yeah, so we created mean queue time receptionist within the run, and we set it to 0. So what we're going to have here is self.mean queue time for the receptionist in the run, and we're going to say self.results data frame. We're going to pull out the queue time receptionist column. So remember, we've got this column called queue time receptionist, and we're basically just going to pull out a list, more or less, of every time. So if we imagine we had 100 patients here, we'd have 100 times in a list that are all decimal numbers, and we are just going to use the mean method. So this looks at this, what's actually called a pandas series, but you don't need to worry too much about that, and calculates the mean of every value within it. And we've made this as something that we will, as a method, we have to remember to call this when we run our simulation effectively. Otherwise, we'll never calculate this mean queue time for the receptionist, and actually what will happen is it will stay as 0. So let's do something else. So now we just need to run the simulation. So let's do def run self, and this is the last method we need to define for our model. We are going to first go into our simulated environment and say, please start generating patient arrivals. Now, if we had multiple types of patient arrivals, so when we get to talking about the patient, the callers later, we could have something like this, generator caller arrivals. You can have as many different kinds of generators going as you want, as long as you've defined what will happen with each of them when they get there. But for now, we've just got our patient arrivals, and what we're going to then do is we are going to run the model. We're going to say, please keep running this model until the end of the simulation. So we set our sim duration, remember all the way back up here, as 60 minutes times 8 hours, so 480 minutes. So it'll keep running until that point. And then we will break out effectively. Remember, we had this infinite loop where we were generating patient arrivals. That will all stop. We'll stop generating patients and the model will effectively have finished running. At this point, we want to run our calculate run results method. So we could actually be calculating lots of different results. So we could calculate the median, we could calculate the variance or the the quartiles or something of our different of our receptionists, or we could be calculating the average for lots of different. We could be calculating the average for lots of different types of things. So we could actually, if we're queuing for receptionists, GPs, etc., then that is what we will have built, or we will be calculating there. But for now, we're just going to calculate one thing, and it won't happen until we've finished running the simulation. Finally, for now, we are going to print the patient level results. This is just a good way to check that the model is working as expected. We can always comment this out later or remove it entirely, but commenting out is quite nice because if we make some modifications and want to check everything's running again, then we can get this back quite easily. We're going to print, and we're going to have an F string here where we're going to print the run number, and we're going to have the self.run number. Remember, we recorded that way back at the beginning in our init method of the model class. And then we are going to print the results data frame. And I'm also, no, we'll print the averages somewhere else. So let's not worry about that. But that is our model class complete. Now that took a little bit longer, but you can see that each little bit of it is quite self-contained. And actually, when you compare it to this model, or this example on the right, you can see a lot of this is just comments. There is not actually that much code to create this initial model. I should be commenting this more. You should be commenting it probably a little bit more than I have done so here. But for now, just to make it easy to just keep track of what we're doing, I haven't written too many comments, other than where I might want to come back and do some things. So actually, let's make a few comments. Calculate the averages. It's the run, so we're going to remember that actually if we want to add another average for a different thing, then we'll be doing it there. And actually here we're going to basically define the steps of the patient journey, which we'll need to do here. We probably won't really need to modify this one, the generated patient arrivals, because actually all we're doing is we're passing it into this attend clinic method, and that's what we'll be building in our additional steps in. So where they go on to see the GP, where they go on to potentially see the potentially have go back to the receptionist and book a test, where that's that sort of branching path. Some of them will, some of them won't. But that is all that needs to happen there. And we probably won't modify this run method, to be honest, other than potentially, as we said, if we want to have an additional class of patient arrival, so have the callers arriving as a sort of separate generation because they are sort of completely separate. And actually, because we've been told they arrive every 10 minutes, it's a lot easier to define a new set of patients who will arrive every 10 minutes rather than trying to do some sort of sampling to say, oh, okay, this kind of patient will arrive every X minutes, or if a patient arrives at these intervals, then actually there'll be a caller rather than a patient, and it'll all get a little bit messy if we try and do it that way. So it's easier to just have a new kind of patient being generated, and for those kind of patients, we will then be able to define what happens to them. So remember, when we generated them, we passed them to the attend clinic process. Well, what we'll do instead is we'll pass them to a call GP surgery process. So it's all defined quite self-contained. So we'll just be duplicating these methods for that different class of patient, but we'll do that in the next or a later video. So what else do we need to do? Well, we need to create a trial method. But first, let's see what happens. Can I run just one instance of this model so you can get a little bit of a sense of what this looks like? So I'm going to create this test model. So remember, we've just got run number 1, and then I'm going to run it. And you can see what we've got is a queue time for the receptionist. We have got 181 patients in the time that we had. And some of the later ones were queuing for 2.75 minutes, etc. So that is all good. That's all we did in the calculate run results. So actually, if I were to my test model now and access this attribute, let's go back up to the top. What do we call the attribute? So it's mean queue time. Oh, what have I done here? I broke something. Oh, I turned it into a markdown cell. That was impressive. There we go. Mean queue time receptionist run. And you can see at the bottom now, I've got a printout of 2.53 minutes. Now, what happens if I keep running this? Yep, so you can see every time I've run it, I'm getting a different mean queue time. And actually, that's kind of to be expected because we're randomly sampling. And this is exactly what we want, in all honesty. We want to be getting different times that the patients are arriving, etc. So we are getting this different mean queue time across the run, and you can see as well our values in this table are changing. What we've got are the first 5 patients and the last 5 patients. So Pandas has been nice to us because effectively we've created quite a long data frame and it's gone, I'm not going to print the whole thing because, you know, that's going to make a right mess of your screen. Let's just print you a little bit of a sample of it so you can get a sense of what's in this data frame. Now, I think the other interesting thing to note is these final patients where we've got a queue time of 0. That could be what we were talking about earlier, where I was saying, oh, we need to be a little bit careful with what our wait time is for our patients. So they queued for the receptionist and we've set that to a default of 0. I'm just going to try setting it to none. Let's see what happens because this might break. And I'll just need to run it a few times. We're still getting zeros, so that's not quite what we're looking for. Let's try changing this to 999 and run this a few more times. Nope, that's also good. And actually, I think we are fine here because I was a little bit worried that these were not actually accurate times, that maybe they were patients who had turned up, been put into the system, but we'd never actually got to the point of recording their time in the system, their queuing time. So actually, they'd started queuing, they'd never finished queuing, and therefore it defaulted to 0. But I think actually, because of the way we wrote this, so if I pull this across a little bit so we can see better a second. So we've got our queue time for our receptionist, our queue. So where do we put them into the data frame? So yeah, we don't put them into the data frame until they have received a receptionist, effectively. So if someone enters our system and never gets seen, then they won't end up in our data frame. So that's probably a good thing. That's actually what we want for now, because otherwise those patients who've turned up and not been seen by a receptionist will sort of skew our times. However, again, still something to be aware of, because what we could be having here is effectively additional people turning up and waiting an extremely long time but not being recorded in our model because we haven't put them into our data frame, so we're not necessarily aware of how many patients were actually turning up. So one thing I'm going to add to my run method a second, let's see if this will work. Let's print at the bottom underneath our results data frame, print, can we access model, well, self actually, patient counter. And let's put, there were this many patients, and we're also going to print our data frame contains self dot results df. I think off the top of my head we can run, is it n row? I might be mixing up with a different language here. Let's try length of the results data frame, so how many rows are there in our data frame. Going to run this again. Remember, we need to run this so that our methods and our classes actually update. And then I'm going to do this. Right, so our data frame contains 148, 153, 158. So actually, yeah, we finally got to an example. We've got, there were 181 patients who turned up. Our data frame only contains 180. I'm going to run the simulation for a little bit longer and see what happens. So let's imagine it's not very realistic because of course we're then turning it into almost like a 24-hour GP surgery, which isn't true, or assuming that everyone who's queuing at the beginning of or queuing at the end of the night sits there overnight and waits until we open up again. Not exactly realistic, but just to show you the impact of this across longer simulation runs, you can see, oh, no, actually that was fine. Queue didn't build up too much, and that's probably because actually all we're doing is waiting for one receptionist and it doesn't take very long for them to be seen. What happens if we change it so that actually it tends to take about 5 minutes to be registered and we've still only got the one receptionist and every 3 minutes between our patients turning up? So I've rerun this so that actually our global class updates, the sort of default parameters going into the model are changing. And you can see this time we had 2,034 patients who turned up, so actually counted into our system. Our data frame only contains the weights for 1,154 of them. And you can see again at the beginning we didn't have too much of a problem, we didn't really have queues. By the end we've got patients waiting 2,500 minutes to be seen by a receptionist. But the next patient in that queue, 1155, never got seen, even though they've been sitting in that waiting room for probably around about 2,500 minutes. So it's just worth being aware. Just keep in mind what you're recording and what you're not recording when you're doing a simulation model. It's really important to be mindful of that. Now I'm going to go back and change this to every 2 minutes, and we're only recording for that long. So that is all back to where it should be. And I'm going to get rid of these print statements. For now, I'm going to comment them out just because I think we don't need them right now. And again, I'm going to rerun this little section. And if I run this model again now, then we can see that, yeah, we've got run number 1 and we did 2.9. So, last thing, we're nearly there. We are going to create a trial class. Now the trial class is where we're going to start doing these multiple runs. So actually here, every time I wanted to get another run, I had to click this and rerun it again, and you can see the values are updating. Well, let's get Python to do that for us now. So we are going to initialize our class, or define the code that will run when we create a new trial, a new object of the class trial. I'm going to create another data frame. So this is where we are going to store the results from all of our trials, the average across, well, not the average across actually. First, we're going to store for each run, we're going to have a row that will have the results for that run. So pd.dataframe, new data frame again, self.df trial results, and do the run number, and that's going to start with run 0. And again, this will probably feel quite familiar to what we were doing with the patient level data frame. We're going to then have a column for the mean queue time, just for my own sanity, mean queue time for receptionist. We're going to again set that to a default of 0.0. And we're going to have the trial results. We're going to set the index again, so this is all feeling quite familiar, very much the same as what we were doing before. We're going to set the run number to be the index. So if I were to create I'm just going to not run that a second, let's just, so we haven't got that. I'm going to create my test trial. So I'm going to create a trial class. We don't need to pass anything in. See, we didn't actually pass anything into the init method. We've just passed self in. So we don't need to, unlike, and actually I've put model there, I meant to put file. So unlike here where we had to pass in the run number, this time we don't pass anything in. If I run this, you can see it's run successfully. If I now access my test trial, if I access the df trial results attribute, you can see that we've got another data frame where we've got a column with the mean queue time for the receptionist and the run number. Now, what are we going to do next? We are going to basically print out the results. So we're going to create a method that allows us to print the results. We haven't created the results yet, but we're going to want to be able to print them. So I'm going to print the trial, I'm going to call this print trial results, just like the code example itself. And I'm going to print trial results. So this is just going to create a column, or sorry, a line in our output that prints the words trial results. And then I'm going to print the trial results, this data frame. So what we were doing here a second ago where we had to access the attribute, well, just doing the same thing here, but inside a method that we can call as part of our, well, as part of our next bit. So we are going to create a method that will run a trial. Again, self, passed in as usual, and then we are going to run multiple trials. So we are going to have, let's say for run, in range G number of runs, and what we are going to do for now, just so I can show you what's going to happen here, I'm going to print run. So let's run that again, and this time I'm going to do my test trial. I'm going to use the run trial method. Now you can see what's printed out here is I've just printed out 0, 1, 2, 3, 4, 5, and so on all the way up to 99. So all we're doing, this run parameter that comes in, is a number. We're creating a range object up to and including the number of, well, not up to and including the number of runs, actually it'll be one less than the number of runs, but we start at 0, so we go from 0 up to 99, 100 runs. Remember, we specified that all the way back in our G class. So rather than just printing what run we are on, we are going to use our model class. So we're going to create a model. So let's do model. And then remember, we needed to pass in the run. So run number becomes run. So now we will have a new model with run 0, run 1, run 2, so on and so forth. We can then do please run this model. So remember, we have got this run method of our model, and what the run method will do is actually start this generator process, run the simulation until the end, calculate the run results, and print those run results out. And also, as part of this process, it will create this mean queue time receptionist run attribute, which we can then access out of our model class. So what are we going to do with this? Right, let's go back. My model. I'm going to run the model. Then we are also going to store in our data frame trial. So we're going to, in our data frame here, and actually I'm not going to follow this pattern. Let's do it a little bit more like what we were doing before. So how are we storing it? We were using at, and I think it would make more sense to do it like this rather than what's done in the code example, just because it's a little bit more consistent. So I copied this in, but actually we want to look at the DF trial results. We are going to put it in the run, and we are going to be storing the mean queue time for the receptionist. Then we want to be able to access, or what we're going to pass in is my model. And if I press dot here, you can see that we've got a couple of things, and it's the mean queue time for the receptionist in the run that we want to store. Finally, once all of that is stored, what we're going to do is we're going to print the trial results. So we want to access this print trial results method, and note that this is outside of our for loop. So what we're saying is for 100 runs, please go through, create a new model, run that model, store the mean results from that model in this data frame that we created as part of our trial method. And at the very end, when you've done all 100 runs, please can you now run this code here, print the line trial results and print self.df trial results, this data frame. So we are very nearly there. Finished defining all our classes here. So I'm going to just create, instead I've saved those and in a new cell so that we don't have to so that we can edit our classes separately of the code we're going to use to run this. I'm going to create a new trial as we did a minute ago, and I'm going to do my trial run trial, and let's run this. And you can see what we've got is run 0, run 1, run 1, and so on. I'm going to change this to a scrollable element just so we can get through the whole lot. So 0, 1, 2, 4. Again, remember it's just showing as a sample the first 5 patients and the last 5 patients. You can see we've had a different number of patients between runs. That's because of that randomness and the inter-arrival time. So they're 155, 154, 147, 156, so on and so forth. What I am interested in though is this bit at the bottom. So now you can see that we have got run 0, run 1, run 2, run 3, and so on and so forth. So we have got this trial results, and we have got the mean queue time for the receptionist across all of these different runs. The final thing I'm going to do is I'm going to add in something to the print trial results method. I'm going to print average receptionist queue time across runs, and I mean be aware you're calculating an average of an average here, but for the purposes, I want to look at self.df trial results. I want to pull in the mean, what do we call it, mean queue time receptionist, and I want to calculate the mean of that whole lot. So a little bit of a mess here because it's not good practice. I've made this longer than 80 lines, or 80, it might even be 100 actually set up in mind, so it's quite a long line of code. We really should split this, but for the purposes of here, all we're doing is we're going to print the average queue time across runs, just so we can get a sense of how well our model is working. So, and actually just for now, I have broken my F string. Why have I broken my F string? Because I tried to use double quotes around my column name. And actually it's then trying to match that double quote at the beginning of my F string with that double quote when it ran into it, which is not good. So let's run that again, run the trial again, and now I'm going to scroll all the way to the bottom again. And you can see this time we have got the average receptionist queue time across all of our runs is 3.5 minutes. So just to make it a little bit easier to, we're not going to print, actually we'll keep printing the trial results. And remember what I said earlier about, getting rid or temporarily commenting things out. I'm going to comment out this run number 1, this where we're printing out the result, the patient level results for every run. If I run this again now, you can see all we get is the trial results, so the 1 row per trial, and the average receptionist queue time across all of these runs. If I were to run this again because of the randomness, we would see a slightly different set of results, 3.59 average this time, but to be honest, they'll probably be quite similar because we are doing this whole thing of averaging across a large number of theoretical days. What else could we do here? We could, out of interest, let's access DF trial results, and we will access that column. So mean queue time receptionist. So you can see this time it hasn't, because I've basically not told it to actually do the whole, I cheekily haven't run the trial there, actually that's not very helpful, is it? So if I get rid of that second, we'd still need to run the trial, otherwise nothing will actually happen. I'm just going to get rid of that step where we print the results as well, just for the purposes of this demonstration. So now you can see when I pull back the DF trial results, this is what we've got. We've got this sort of column. But benefit here is I can now start to access the maximum, the minimum, and the median, just so I can show you what variation we might be seeing. So here we've got, and because I didn't tell it to print, so I'll just show you one of these at a time actually for now. So it will only print in Excel, it will only show us the last thing. If there's multiple outputs, it will show us the last one. So maximum queue time, what did we see in this instance? Well, and I'm just going to comment that out so I'm not rerunning the trial. It ran 9.66 was the longest queue time seen across all of our results. 0.99 was the shortest average queue time seen across all our results, and the median average queue time we saw was 3.2, and if I were to change that to mean in this case, so 3.2 median, 3.66 mean, slightly longer mean. So don't worry too much about that, but just to show you, you can access and start calculating different things about your results, and you could build that into these methods as well. You could be calculating all sorts of things. Instead of just having the mean here, we could use that in this bit, and maybe we could calculate the well, we can do all sorts. We'll cover that in a later video when we go more into tracking different kinds of results for the clients, in this case for our GP surgery. But for now, if I go back through and actually just make sure these print methods are running, then we have done the first part of this. We have done patients arriving at GP surgery, being registered, and then leaving. In the next video, I will go through adding in this additional GP consult step, adding in this book test loop or this book test conditional step, and also adding in the answering call additional step. Now, because we have done all of the setup for our model, the next video will be much quicker because we're only adding in these additional steps, and it will be much easier, and you'll start to see where all of this foundation that we have set up will pay off. So, thanks very much for watching, and I will see you in the next video.